Hey everybody, welcome back to the second last lesson in this unit, solving rational equations. So up until this point, we've been working with expressions, equations. We can finally answer math's greatest question: what is x? So this should be a little bit easier than the last lesson. Hey, that's good news, because remember I told you adding and subtracting of rationals is the most difficult thing, I think, in 30-2. Well, that makes what we're about to do today hopefully not as difficult. So, what's the difference between an expression and an equation? Well, simply we got this flying around. We got an equal sign in between the left-hand side and the right-hand side. So we can actually answer the question of what is x. Okay, there's more than one way to do this. Okay, there's more than one way to solve a rational equation. This is what I'm going to do. Like I said, there's more than one way to do this. So if you like a different way, or someone showed you a different way and you're like, oh, I like this, yeah, I don't care. Do what you want. I'm just going to show you what I think is the best way. Okay, I'm going to skip over some of the stuff. I'm going to go right to here. It says, solve the following equations, meaning, what is x? State any restrictions. So, first step, can I factor? Nope, monomials. Step 2, NPVs. Nope, because these are all just numbers. Step 3, what's my common denominator? Well, my common denominator of 4, 3, and 2, well, my common denominator is going to be 12. So, if the common denominator is 12, I'm going to multiply the first term by 1 in a sneaky way, 3 over 3, second term by 4 over 4, third term by 6 over 6. So that's 9x over 12. Oops, I got one too many equal signs there. I did not do that on purpose. Don't write two sets of equal signs. I was still in expression land there. And then 42 over 12. So far, so good? Now, here comes the really important part. This is an equation, meaning the left-hand side is equal to the right-hand side. I'm going to look at this and say, if this is an equation, the numerators and the denominators, I'm going to look at this two separate pieces. Look at my denominators are all the same now. Well, if my denominators are all the same, what that tells me then, if the left-hand side is equal to the right-hand side and the denominators are equal to each other, then guess what? The numerators have to be equal to each other. So therefore, 9x minus 20 is equal to 42. I did not simply cancel the denominators. People love to say that. They love to cross off the denominators. No, if the left-hand side is equal to the right-hand side and I have a common denominator, then guess what? The numerators are equal to each other. It's not magic, it's logic. And now all we need to do is isolate for x. So move the 20 to the other side by adding 20 and then divide by 9. There it is. Now, if I want to check my work, what I'm going to do is I'm going to take this answer and I'm going to shove it, substitute it back in for x. If the left-hand side is equal to the right-hand side, numerically, I have done this correctly. I highly suggest on a test you do that. I will make a video to follow this one, just like before, to show you a couple hints to use on your calculator, especially if it's a multiple choice or numeric response question. Okay, this one here, the first one, yeah, there's some key things in there, but that's not the question you're going to get. There's no variables in the denominator. Let's take a look at number 2. Number 2. So I go through my steps again. Step 1, factor. Nothing. Step 2, NPV. Sure. X can't equal 1/3. Okay, what's my common denominator? Well, my common denominator will be, you know what I'm going to do? I'm just going to erase over here. What's my common denominator? My common denominator will be 2 over 3x minus 1. There's my common denominator. So the left-hand side requires a 2 and a 2. And I apparently did not have enough coffee before I started this video. Okay, and on the right-hand side, we need a 3x minus 1 over a 3x minus 1. Like it. Now that I have a common denominator, and it's an equation, if the left-hand side is equal to the right-hand side, and the denominators are the same, therefore the numerators are equal. Okay. Now all I need to do is isolate for x, so I'm just going to begin some distributions. I like to bring all my x's to the left-hand side, so I'm going to subtract 9x from both sides and add 8 to both sides. And there it is, x equals 5. Again, a very simple way to check my work. I sub 5 in for the x's up here, and if the left-hand side is equal to 3 over 2 or 1.5, then I know I've done this correctly. Okay, so question 2, now we're starting to get into some grade 12 stuff. 30-2 goodness. All right, a couple more to try. Step number 1 on number 3, can I factor? Sir, yes, sir. There's an x that I have as a greatest common factor right there. I also notice on my right-hand side, hey, look at that. There's a subtraction. Every time there's a subtraction, what's he doing? Messing with me. Okay, non-permissible values, 0 and 3. Common denominator, I'm just going to write it over here because I'm running out of room, is x and x minus 3. Alrighty then, the left-hand side already has the common denominator. So on the right-hand side, the first term needs x over x. And the second term on the right-hand side needs an x minus 3 and an x minus 3. If it's an equation and I have a common denominator, that means the numerators must be equal. Therefore, 18 is equal to 6x minus 5, x minus 3. And from here, slowly just start simplifying. It's a subtraction. So remember my warning from the other day, make sure you distribute that negative. So it's plus 15. 6x minus x is 1x. Subtract 15. So I get x is equal to 3. And I'm done the question, right? X equals 3. Wait a minute. What were my non-permissible values? Back at the beginning, I boxed it and I said, hey, look at x can't equal 0 and x can't equal 3. But what did I just say my answer was? I just said my answer was 3. Oh, no. Wrong. This is very, very important. X cannot be 3. It says it right beside there, my non-permissible values. So what you're going to do is you're going to cross this off and you're going to say extraneous. It's not a real solution. Guess what? In fact, there is no solution to this question. There's nothing that's going to make the left-hand side equal to the right-hand side. So for my final step, what I need you looking for in equations is to say, is my answer one of my non-permissible values? That is a huge deal. All right, number 4. First step, can I factor? Oh yeah, right on the right-hand side. So I'm always factoring. It's the first step in everything in this unit. Okay, non-permissible values, x can't equal positive negative 3. Common denominator, I'm pretty sure you can see is x plus 3, x minus 3. So this needs an x minus 3. This needs an x plus 3. In an equation, if the left-hand side is equal to the right-hand side and I have a common denominator, that means the numerators are equal. Okay, so I just write that step down. And now I start simplifying. So I need to do some distribution. So 2x squared minus 6x plus x squared plus 3x is equal to 18. 2x squared plus x squared sounds like 3x squared. Minus 6x plus 3x is minus 3x. And I'm going to subtract that 18 over because I've got a trinomial. And when I have a trinomial, I know that I want one side equal to 0. Do you notice we can factor out a 3? Or I'm going to divide everything by 3. I'm allowed to do that because 0 divided by 3 is 0. And what I did to one side, I did to the other. It kept my equilibrium, my balance. Now I can factor this. This will be x minus 3, x plus 2 is equal to 0. Therefore, x is equal to 3, comma, negative 2. But I go back and I look at my non-permissible values. Wait a minute. I said x can't be 3. So that's my extraneous one. So my answer will be x is equal to negative 2. Love it. That is a fantastic question. I'm going to go to my stamps, which I love so much here. I'm going to make a big, beautiful heart. Look at that, a heart out of hearts. Know this question. Hint, hint, nudge, nudge, wink, wink. Probably going to be on a test. Okay, what you need here is just some more practice. But once you get the hang of equations, it's a lot easier than adding and subtracting. To solve a rational equation means to find the solutions or the roots is sometimes what you'll hear. To solve a rational equation, first, we know, no surprise, factor, factor, factor. Okay, find the common denominator. Yeah. You should not have fractions after this step. No matter what method you're doing, you should not have fractions after this step. Simplify and isolate the variable. Remember, we must always check the solutions with our NPVs. If one of our solutions is one of our non-permissible values, then we have an extraneous root. I need you to cross that off and label it for me. We should always check our work or verify our work by substituting our solutions back into the original equation. We can always check our work by graphing. And that's what my next video is going to be on, okay? So there'll be a small video that follows this one. It's a little tricky, but I want you to check it. Now, a couple little hints here. If I end up with something like x cubed or x to the fourth, you probably did screw up. We don't factor those things in 30-2, just 30-1. So I want you to look for it. Okay, friends, there it is. One more lesson to go in this unit on applications, and you are done the hardest unit of the year. Fantastic. See you next time.